Hello everyone. In today's lesson, we will be learning how to set up and solve optimization problems. Now here are some steps in setting up and solving optimization problems. 1. Draw a picture if possible and label all the variables. 2. Determine which quantity is to be maximized or minimized and for what range of values of the other variables. 3. Write a formula for the quantity to be maximized or minimized in terms of the other variables. This formula may involve more than one variable. 4. Write any equations relating the independent variables in the formula from step 3. Use the equations to write the quantity to be maximized or minimized as a function of one variable. 5. Identify the domain of consideration for the function in step 4 based on the physical problem to be solved. And 6. Locate the maximum or minimum value for the function in step 4. This step usually involves looking for critical points and evaluating a function at the end points. Now, let us look at a problem. A basic problem. Find two positive numbers that satisfy the given requirements. The product is 48, and the sum of the first 3 times the second is a minimum. Solution. Let us assign some variables to these numbers. So let these numbers be called x and y. Now x times y is equal to 48, and that is a product. That is a constraint. And then the sum, x plus 3y, that equals s. So s is equal to x plus 3y. And the sum is the thing that we want to minimize given our constraint, which is a product, x times y equals 48. We want to solve the product for y and then plug in that value for y into the sum function. You might want to ask, could we have solved it for x first instead? Yes, you could. Okay, so you could do it for either variable, but we are trying to solve it for y first here. So then, because x times y was equal to 48, then y will be equal to 48 over x. We plug this 48 over x for y in your sum function, x plus 3y. So then, we will have x plus 3 times 48 over x being our sum. So now, if we use algebra to simplify that a little bit, we will have our sum is equal to x plus 144 over x. Now, we want to maximize, find the maximum or minimum. So we take your derivative, take a derivative of the sum function. So ds dx, or if you wanted to call that s prime of x or s prime, you could do so. ds dx is equal to 1 minus 144 x raised to the negative 2. You can write that as 1 minus 144 over x squared. So then, we set this derivative is equal to 0. That's not the maximum or minimum. The derivative is equal to 0. So 1 minus 144 over x squared is equal to 0. And then using our algebra, we try to solve this. 1 would be equal to 144 over x squared. Therefore, 1 over 144 is equal to 1 over x squared. So 144 is equal to x squared. So x would be equal to 12. We are choosing the positive root. We're not worried about the negative root because the question said find positive numbers. Okay? So then if x is equal to 12, y is equal to 48 over 12, so then y will be equal to 4. Okay, now how do we know if this is at a maximum or a minimum? We have to do another test, right? We have to do another test. Let's do this second derivative test. And what we do, we find the second derivative, and the second derivative is positive. Second derivative is positive. That means our function will be concave up. Concave up, so that's what this sign here means. So then the sum is a minimum, and that occurs when x equals 12 and y equals 4. Let us take a look at another problem. A rectangular garden is to be constructed using a rock wall as one side of the garden and wire fencing for the other 3 sides. There is 100 feet of wire fencing to be used in the construction. A. Determine the dimensions that will create a garden of maximum area. And B. What is the maximum area? Problem. We would like to, first of all, draw a picture. Remember, in some problems, it's probably not necessary to draw pictures, but for this problem, it's nice to sketch a picture. So here is our wall. And the wall has no fence. Okay, the wall has no fence on it. And so, this is a rock wall. It has some green moss on it, probably. And this is what a diagram of this would look like. This situation will look like where we have the 2 sides, and we label them X, that run perpendicular to the wall. And there's another piece of fence here, Y, that runs parallel to the wall. Okay? We have 100 feet of fencing. And so that is our constraint right there. We're constrained to 100 feet of fencing. Our variables then, X, your fence that's perpendicular to the wall. Y, the fence that's parallel to the wall. A is the area of the garden. And P is your perimeter of the fence. This perimeter P will be replaced quickly with 100. So it's okay if you just had written this as 100 plus 2y without identifying a variable P. That's fine if you do that. But for this problem, well, I have put in the P to be equal to 2x plus y, and then replaced it with 100 pretty quickly. That is your constraint. Now, our area is equal to x times y, and so we're trying to solve the parameter equation, for y, and then plug that into the area. Could you have solved it for x first? Yes, you could, but we try to go with any variable that it is easier to solve for. And since there was already only one y here, it's probably easy to do that. Okay? Then, so 100 will be equal to 2x plus y implies that y is equal to 100 minus 2x. Just doing a little bit of algebra there. And you plug this into the area equation. A is equal to x times y. So A will be equal to x times 100 minus 2x. So A will be equal to 100x minus 2x squared. Your domain, you want x to be positive, you want y to be positive, and we can figure out that x will be less than 50 because y is equal to 100 minus 2x, and we only have 100 feet of fencing. Okay, so that is, if you gave all to x, then the most that x could be is 50. So we're restricted to that amount, maximum amount for x. So then I want a maximum x in the interval 0 to 50. And so let's take our derivative. The derivative, that's how you find maximum or minimum. Do your derivative of your function. So a prime would be equal to 100 minus 4x. Set this equal to 0. 100 minus 4x is equal to 0. So 4x is equal to 0, so then x will be equal to 25. And x equal 25, plug in your x equal 25 into a function with y and x to solve for y. So y will be equal to 100 minus 2 times 25. So y will be equal to 50. And so your x and y will be what we call your dimensions, your length and width of your rectangle. So the dimensions to maximize the garden are x equals 25 feet and y is equal to 50 feet. X equals 25 feet, y is equal to 50 feet. And then the maximum area of the garden will be 25 times 50. That'd be 250 feet. Find a point on the curve y is equal to radical x that's closest to the point 30. First of all, we want to set up our diagram with y is equal to root x and just identify the point 30. Identify a possible coordinate on the graph. Y is equal to radical x. That will be x, radical x. And then one way of trying to solve it is to draw a horizontal, a straight line down, a vertical line down, and making a right triangle. So then we can identify dimension of that triangle, 3 minus x, and then there's radical x going down. And then we want to find the distance. Let's call that d on that triangle. So we're going to apply a distance formula idea. Or Pythagorean theorem idea. So here we have our right triangle, and we can use our right triangle. D is equal to radical 3 minus x squared plus radical x squared. Our feasible domain here is 0 to infinity, and then just kind of simplify whatever is in the underneath the radical. So if I keep the 3 minus x squared plus x, and then find the derivative of that radical function. And so if we rewrote this as 3 minus x squared plus x raised to the 1/2, we follow all these steps. The chain rule, we're using the chain rule right here to get all the way down to simplifying this. After you simplify this, you got d prime is equal to 2x minus 5 over 2 radical 3 minus x squared plus x. And then in order to minimize or maximize, we set the derivative equal to 0 and then solve for x. So this is what we're doing right here. So we set in 2x minus 5 over 2 times radical 3 minus x squared plus x equal to 0. We set that numerator equals to 0. That's 2x minus 5 equal to 0. So x will be equal to 5/2. And so y would be equal to radical x from our original equation. So that is going to be radical 5/2. So our final answer is to say that the point closest to 30 is 5/2, radical 5/2. And that is the solution to your our problem. Thank you so very much for watching. Please like and subscribe, and see you next lesson.